Okay, in this video, we have talked about systems of equations with 2 variables and 3 variables and substitution and elimination. As I said, all things being equal, I don't necessarily care which method you use as long as you can algebraically solve a system of equations. But of course, once we understand what systems of equations are, we want to start looking at applications that we can solve with systems of equations. And one thing, we're actually going to look at 2 examples here. We're only going to solve out one of them, but the problems that we look at are actually similar to problems we've already done, which we'll see, and then we're going to kind of expand on it from there. And what I mean is, this one we're not going to solve, but we'll at least set it up. Suppose I have this. Let's see. I invest my money into 2 accounts. The first gives 8% interest. The second gives 5.2% interest. I invest $10,000 total. How much did I invest in each if I end up with $700 in interest? And we're not going to solve this. It's not going to have a nice round number answer or anything, so I'm just making it up. But there's a point here. We solved this problem earlier in the semester. And what we said earlier in the semester was, okay, let's see, how much did I invest in each account? So I'm looking for 2 quantities. So I tried to write both of the quantities in terms of 1 variable. And the trick, if you recall, was we did something like this. X equals the money in the first account. And then since I invested $10,000 total, 10,000 minus X is the money in the second account. Now I have my variables set up for both of the quantities I care about. I create an equation. And we just use the interest formula, I equals PRT. Interest from the first account is the principal X times the rate, 8%, so 0.08. Time I didn't list, so assume it's year 1. Plus principal from the second account, 10,000 minus X, times the rate, 0.052, times time, which is again a year. Now, interest from the first account plus interest from the second account equals total interest, which is 700. And I have a nice simple equation, distribute, solve for X, done, good to go. And we did these earlier in the semester, which is the point. But another way to look at this is to say, well, you know what? If I'm looking for 2 quantities, I'm going to call them X and Y. So X equals the money in the 8% account, and Y equals the money in the 5.2% account. Now I have 2 variables. Now we understand, well, I can just set up a system of equations. The rule is, however many variables you create for how many quantities you're looking for, that's the number of equations you need to generate. And in this case, well, I know I invested $10,000 total, so the amount in X plus the amount in Y has to equal 10,000. And then I have this information about the interest, so the interest in the first account is the principal X times the rate, again, time is 1. Interest from the second account is the principal times the rate times 1. Combined, these have to equal my total interest, which is 700. Now I have 2 equations, 2 unknowns. I can solve that with substitution or elimination. And the trick here is, if I just solved the first equation with substitution for Y, I get Y equals 10,000 minus X. Then we stick that over here for Y, and we get 0.08X plus 0.05, I left off my 2, 0.052 10,000 minus x equals 700. Which is, of course, the exact same as that equation we had over there. And essentially, the idea here is you can set up a lot of these problems with either one variable or two. If you set them up with two, you explicitly write out the system of equations and then generally do substitution or something. But a lot of times you can kind of do the substitution in your head, which is really all we did here. We said if x and y have to equal 10,000, then one of them has to be 10,000 minus the other. Oh, I'll just write that here rather than writing y and kind of using this intermediate equation here. And when you get problems like this, I don't actually care how you solve them. Personally, I prefer doing them with one variable because one is more efficient than two. But I don't really care. What I would suggest, at least as far as your homework goes, if you have a problem that you can solve with one variable, solve it both ways. Just so you can test yourself and say, okay, I know how to solve it here, so solve it this way, make sure my answers agree, which tells me I'm doing it right. Because ultimately, you get to more convoluted problems where you can't kind of just do this substitution in your head, and then you need to be able to write out the system formally and solve it with substitution or elimination. So, as an example, we have plenty of time. We recently went to Universal Studios in Florida, which is great. And of course, the best part about being there is knowing that if you actually want to get like a hot dog and a soda, it's going to cost you like $17.50 because the prices are exorbitant. But that means, suppose we have a problem like this. I go to Universal Studios, and on day one, I buy 3 hot dogs and 2 sodas for $14.50. The next day, I buy 2 hot dogs and 4 sodas for $15. How much does each cost? And we want to set this up, and this one will actually solve out, but well, here this is different from the interest one in that I don't necessarily have a direct relationship between hot dogs and sodas like I did before. Before I had total amount of money invested split into 2 different things. Here it's maybe not as clear how I could write both quantities in terms of one variable. You can do it, but it's rather convoluted, which we'll kind of see in the solution. So for this one, it's actually easier to just say x equals the cost of a hot dog, y equals the cost of a soda. Now create a system of equations. And let's see, in this case, well, I can just talk about the costs. Let's see. On the first day, 3 times the cost of a hot dog, which is x, plus 2 times the cost of a soda, which is y, has to equal $14.50. On the second day, 2 times the cost of a hot dog, plus 4 times the cost of a soda, I want to say this, equals $15. Now I have a system. Solve it all out. And you can kind of choose how you want to solve it. In this case, I don't know, maybe I'll go with elimination. And I'll just multiply the top row by -2. Because then I'll have a -4y and a positive 4y. So if I do that, I get -6x minus 4y equals 1450 times -2, which is -29. On the bottom, I have 2x plus 4y equals 15. Now combine. 2x minus 6x is -4x. 4y minus 4y is 0. 15 minus 29 is negative 14. Now just solve it. Divide the negative 4. X is negative 14 over negative 4. The two negatives cancel. I get 14 over 4, which is 7 over 2, which is 3.5. So it's 350. Now, plug that into, we'll go with this one right here because it'll give me round numbers. 2 times x, which is 350, plus 4y equals 15. 2 times 350 is 7, so 7 plus 4y equals 15. 15 minus 7 is 8. 4y equals 8. Y is equal to 2. And now I know x equals 350 and y equals $2. And I'll actually randomly point out again, because we were just at Universal, this is underselling it. Some of the sodas cost like $5, which just makes no sense whatsoever. But anyway, so we see here with the system, and then in this case elimination, this works really well. If you wanted to try to do that substitution with one variable in your head, essentially what you'd have to do is something like take this equation instead of elimination and do substitution. So I'm going to solve for x. Subtract the 2y, divide the 3. You would get 3x equals 1450 minus 2y, then divide the 3. And your relationship between the two variables would look something like that. Like you could say y and 1450 minus 2y over 3, and then generate one equation. The problem is, that's really not something you're coming up with off the top of your head. So it makes more sense to just use two variables. You're going to do several of these examples, some with two variables, some with three. The principle is still the same. Figure out how many quantities you're looking for, set up those variables, and then however many variables you create, 2 or 3, that's the number of equations you have to generate, and then just substitution or elimination to get an answer.